In the far future, billions of years from now, our galaxy and the Andromeda Galaxy will ultimately collide and merge into a single enormous galaxy. The Milky Way itself is the result of past mergers, as we can tell from the remains of those other galaxies. Astronomers believe that galaxy contacts and mergers are common throughout the universe. Large galaxies in particular evolved over billions of years by merging with smaller galaxies. The enormous elliptical galaxies, the biggest galaxies in the universe, very certainly evolved via mergers. The large and small Magellanic clouds, two of our nearby neighbors, and other irregular galaxies likely acquired their warped forms as a result of gravitational interactions with other galaxies. Since irregular galaxies make up an extra 5% of known galaxies and elliptical galaxies make up around 15%, mergers and interactions clearly affect the sorts of galaxies we see. In addition, between 5% and 25% of all galaxies are seen by astronomers to be merging at the moment. Many of these galaxies experience a dramatic burst of star formation, which clearly suggests a link between galactic interactions and the generation of stars. When galaxies combine, like in the case of the antenna galaxies, the result may be breathtakingly beautiful. These were previously two spiral galaxies of comparable size that were first detected in 1785 and started to collide around 600 million years ago. The majority of their original spiral forms have vanished, but the merger has resulted in a massive quantity of star creation. These galaxies will eventually merge to create one enormous galaxy. More unbalanced galaxy mergers have occurred. The Milky Way is now galactic, cannibalizing our satellite galaxies by stealing their stars. Astronomers have discovered that this isn't the only instance of such cannibalism, based on research on star populations. The development and evolution of galaxies depend largely on interactions, which include bigger galaxies devouring smaller ones and mergers between galaxies of nearly comparable size. According to a study, the earliest known galaxy collision occurred less than 1 billion years after the Big Bang. Galaxies have grown via mergers from simple star clusters to the graceful spirals observed in the present cosmos. Some of the smaller galaxies in our own Milky Way galaxy have been consumed. Before a team discovered galaxy B 1465-666, located roughly 13 billion light-years away, astronomers had no idea when these galaxy pileups began. The Hubble Space Telescope captured images that revealed the galaxy's stars are grouped into two separate blobs. The galaxy, one of the first ever seen, may have been two galaxies merging due to its lobed form. Recent observations made with the Atacama Large Millimeter and Sub-Millimeter Array in Chile that revealed the object's gas divided into two blobs that overlap with the star's clumps reinforced that conclusion. The blobs were traveling at different rates in relation to one another, which is another indication that they are merging galaxies, according to the new data. The researchers came to the conclusion that B 1465-666 is made up of two galaxies that by 760 million years after the Big Bang, if not earlier, were merging. This event resulted in a surge in star formation. According to the researchers, the combined gas of the galaxies was producing 200 solar mass stars yearly, or more than 100 times as many as the Milky Way currently makes. According to new observations, the largest galactic merger yet seen is taking place between four giant galaxies. The collision is providing insight on the formation of the largest galaxies in the cosmos, as well as the reasons behind why many of them stopped creating stars billions of years ago. Mergers are sorted by astronomers into several categories based on the sizes of the merging galaxies. Major mergers link galaxies of nearly equal size, whereas minor mergers combine those of dramatically different sizes, such as joining a dwarf galaxy with one the size of the Milky Way. Researchers have just discovered the largest significant merger to date. It includes four galaxies that are located in the center of the CL 0958 plus 4702 galaxy cluster, which is around 5 billion light-years away from Earth. The Milky Way is the size of 3 of the merging galaxies, while the other is around 3 times as big. The plume of stars. A massive, fan-shaped plume of old, red stars that had seemingly been thrown out of the merging galaxies as they spiraled toward one another was found 360,000 light-years away using infrared observations from the Spitzer Space Telescope. The plume contains nearly 3 Milky Ways worth of stars. The combined galaxies are predicted to merge into a single massive galaxy after about 100 million years, with around half of those stars eventually falling into it and the other half floating freely outside. Old and red. The discovery, however, clarifies a deeper mystery. This explains how the most enormous galaxies in the cosmos are formed. This is due to the fact that the nearest galaxy clusters, which are visible as they are today, 13.7 billion years after the Big Bang, include the most massive galaxies ever seen, which weigh around 10 times as much as the Milky Way. Astronomers can see the 4 newly found merging galaxies as they were 5 billion years ago, since they are 5 billion light-years away. Nature versus nurture. According to the natural scenario, the amount of dark matter where galaxies were born determined the pace at which they developed in the early universe. The theory is that galaxy formation took place more quickly in crowded settings, that ultimately gave rise to clusters than it did in less dense ones. Therefore, galaxies in dense clusters simply grew, merged, and ran out of gas more quickly than galaxies in smaller groupings, like the Milky Way, or in regions of comparatively empty space. In the scenario of nurture, the galaxy's surroundings would influence the pace of star creation. In order to prevent the gas from creating stars, interactions with neighboring galaxies strip or heat the gas. Astronomers have seen for some time that although certain galaxies, like our own Milky Way, seem to have turned down star birth or almost completely stopped the process, whereas some other galaxies generate stars at incredible rates. Although astronomers are aware that the termination of star formation entails the loss of cool gas, it is still unclear why this is the case. Scientists have hypothesized many explanations for this phenomena, such as the possibility that supermassive black holes or supernovas blow away or heat gas to the point that it can no longer cluster together, or that galaxies are simply lacking in elements for star formation. Galactic collisions may be a factor in the cessation of star formation, according to new observations of a merger and the tail of gas and dust it ripped from the galaxy it produced, repairing a galactic murder. Long ago, the Milky Way and other surrounding galaxies began to slow star formation. This means that scientists need to search deeper into space, and therefore further back in time to find galaxies that have just recently stopped creating stars in order to comprehend what is causing these galaxies to die. The researchers utilized information from the Sloan Digital Sky Survey, a project to catalogue millions of galaxies based on observations from a telescope at Apache Point Observatory in New Mexico, to search for a galaxy with recently quenched star creation. The team was able to locate a post-starburst galaxy between 6 and 7 billion light-years away that still had signs of having cool gas capable of star formation. The scientists discovered a tail of gas produced by a merger when they used the Hubble Space Telescope to take another look at the galaxy. The cataclysmic explosion and the powerful gravitational forces that would have ripped gas and stars from the galaxies and flung them hundreds of millions of light-years, twice the breadth of the Milky Way, were recreated using this special structure. Despite the fact that there are several large gaps in space, all of the largest galaxies are found there. For a system this enormous, you expect to see these types of big collisions once every 10 billion years or so. Thanks for watching. Do us a favor, hit the like button and subscribe to the channel. Until next time.